Okay, we are in grade 10. We are doing mathematics revisions. We are actually revising exam questions. Okay, we are going through certain topics in mathematics that are going to profit you in the exam. Okay, now this is part 2A. All right, now we question 1 we will focus on basic operations. We will focus on basic operations. Here we are looking at how to add, how to subtract, how to multiply, and how to divide types of numbers. Here we are going to focus on fractions, okay, and decimals. Okay, now we may have this. We may have this this question. Let's say 3/4 plus 1/2, and then you are asked to work out. Okay, so what has to come into your mind right here is you must ask yourself this question: what type of numbers am I working with? Okay, then you realize I'm working with fractions. So what am I doing to fractions? Then you say I am adding them. Then the next question: what is the procedure? Okay, what is the procedure for adding fractions? So the basic operation here is addition of fraction. Okay, now you need to look at the denominators. This 4 and 2, these are the denominators. Then you look at the lowest common multiple of these denominators. Okay, the lowest common multiple. That means you are going to look at the multiples of 4 and then look at the multiples of 2. Then look at the common multiples, meaning multiples that appear in both sets. Then amongst them, look at the lowest. Okay, you will realize that the lowest common multiple of 4 and 2 is actually 4. All right, so then you just draw a line like this and put 4 below. Then we are going to say 4 into 4, it goes once, it goes one time. Then we say that 1 multiply by 3, then it becomes 3. Okay, then we say plus 2 into 4 goes 2 times. Then 2 times the numerator here, which is 1, is going to be 2. Okay, so now having done this, you will then say, okay, you are aware that here you have a fraction here. 3 plus 2 all over 4 is a fraction. Then we simplify the numerator. Then the numerator becomes 3 plus 2, which is 5, over the denominator, which is 4. Then this is an improper fraction. Then you can simplify it and say 4 into 5 goes once, and the remainder is 1 over 4. So the answer is 1 and 1/4. Okay? Yeah. Now, let's say you have this scenario. You have so now this was just addition of fractions, the procedure. The most important thing is the procedure. Now let's say you had the same fractions, but this time it's 3/4, then minus 1/2. The same fractions, but we are now subtracting. Okay, so when you subtract, you follow the same procedure as when you are adding fractions. So what are we going to do? We are going to have this situation. We are going to say this is equal to, then we draw our line. We look at the lowest common multiple of 4 and 2, or LCM. Then we realize that it's 4. Okay? Then you say 4 into 4 goes once. 1 times 3 is 3. We put down our negative. Then 2 into 4 goes 2 times. 2 times 1 here is 2. All right? So what we have now, we are going to simplify the numerator. 3 minus 2 is 1. All right? Then over 4. So the answer is 1/4. All right? The answer is 1/4. Let me clarify this. Let me just clarify the issue of LCM, lowest common multiple. So we were looking at the lowest common multiple of 4 and 2. So first of all, you can find the multiples of 4. Then that would be what? That would be 4 times 1, which is 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16, and so on. Okay? Those are the multiples of 4. Now, let's look at the multiples of 2. Okay? The multiples of 2, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8, and so on. Okay? Now, let's look at the common multiples. You will realize that 4 is common because it appears in both sets. And 8 is also common because it appears in both sets. This one and this one, this one and this one. They are common multiples. But now, that means common multiples would be I'm sorry. It would be what? It would be 4, okay? 4, 8. These are the common multiples. Okay? Now what we use here, we use the lowest common multiple. So amongst this, the lowest is 4. So that means, therefore, the lowest common multiple equals to 4. Okay? That is why we use 4. That is why I just wanted to clarify this. How do we find the lowest common multiple? Okay? Now, let's continue. Let's say we have the same fractions, 3 over 4 times 1 over 2. What I'm interested in is the procedure. So when you add a fraction, when you subtract a fraction, what do you do? What are the steps to follow? Then when you multiply, let's look at when you multiply the same fraction, because we have discovered that when you add it and when you subtract it, you follow the same procedure. Do you follow the same procedure when you multiply these fractions? No. The answer is no. All right, let's see what you do. You cannot say, what I'm trying to say here is that you are not going to look for the lowest common multiple here like we did in addition and subtraction. Okay, here what you do is just to multiply straight away. So this becomes 3 times 1 is 3 over 4 times 2, which is 8. Done. Okay, you are done. There is no need to find the LCM when you are multiplying fractions. You do that only when you are adding and when you are subtracting fractions. That's when you will draw this line and put the LCM of the denominators here and then continue. Okay? When you multiply, you just identify the numerators. You multiply a numerator by a numerator, you get the answer. You multiply the denominator by the denominator, you get the answer. Done and dusted. All right, now let's continue. I want you to be good at this. I want you to be good at this. My prayer is to see you the best mathematician ever in a very near future. Right, now let's see. We still have the same fraction. I'm interested in showing you the procedure. Okay, now we have this situation. What do you do here? What do you do? No, don't think like that, please. Are you saying you are going to say 3 divided by 1? And then 4 divided by 2. No, you do that only when you multiply. So the procedure here, no, don't tell me that. Somebody's thinking, oh, then we will have to find the LCM then. No again. No. Okay? What we do here is this. Okay? What we do here is this. Now that you are dividing by a fraction, every time you divide by a fraction, whether you are dividing a fraction by a fraction, or a whole number by a fraction, or a decimal by a fraction, as long as you are dividing by a fraction, you change the division sign into multiplication. This is what we do. 3 over 4. Okay? Now, look at this. Look at this. Look at this. Look at this now. Time is, okay? Ta-da! Now look at this again. Look at this again. Time is 2 over 1. Something has happened here. A miracle, which pastors never talk about. This is a miracle that only mathematicians will talk about, all right? Look, we took this fraction as it is, right? It's here. It's 4 over 3. But we changed the division sign into multiplication. Not only that, after having changed the division sign into multiplication, we turned this fraction upside down. That's the procedure. After having done this, then you do what you would do here when you multiply a fraction. We are now at this stage of multiplication of fractions. So what do we do now? We just multiply the numerator by the numerator. So we are going to have 3 times 2, 6. Okay? 4 times 1, 4. All right? So we have an improper fraction. So the answer would be 4 into 6 goes once. It leaves 2 over 4. So 2 over 4 can be simplified. So we can say, okay, this is approximately, or not approximately actually, it's equal to 1, okay? 1 over 4. No. 1 over 2. Yeah, it's half, okay? 1 over 2, right? So we have 1 over 2, okay? So that would be the answer. So let's recap. When you are adding, subtracting, multiplying, and dividing fractions, there are certain laws, there are certain restrictions. There is a logic that you need to consider first. Before you can do anything, think of the order, think of the procedure. Okay? So when you add and subtract, you follow the same procedure using the LCM, all right? But when you multiply, you don't look for the LCM, you just multiply the numerator by the numerator and the denominator by the denominator. When you divide by a fraction, you change the division sign into multiplication and then turn the succeeding fraction upside down. Then you multiply. Okay? That's correct. Happy? Yes, I'm happy also. Okay, now let's look at another example here under basic operations. Okay, let's look at another example. This one it's going to be very interesting. Let's see what we have here. We have 2.5 divided by 5. 2.5 divided by 5. Okay, now what we have here, we have a mixed fraction, all right, and then it's divided by a whole number. So we are working on mixed numbers and whole numbers, and the operation is division. Okay, now we will switch to something very important. Let's change this mixed fraction or mixed number into an improper fraction. What do? We just say 2 times 2, then we say add 1. 2 times 2 is 4 plus 1 is 5. over the denominator here, which is 2, divided by 5. Okay? So to make it simple, since you are dividing by a whole number and you are dividing a fraction by a whole number, it is not going to be easy. So it's better for you to change this whole number into a fraction. How do you do that? You just divide it by 1. Who will blame you? No one. You have done the right thing. You have tried to simplify your approach. Then now, you are saying, I have decided to divide by a fraction. So when I divide by a fraction, I just have to change the division sign into multiplication sign first, and then turn this my fraction upside down. No one will whip you for that. No one will punish you for that. Okay? Let's see. Now, that means we are going to have 5 over 2, then our special moment of changing the division sign into the multiplication sign. Then you don't only do that, but you also have to do what? You also have to change to turn this fraction upside down. So you have 1 over 5. Okay? So now you are multiplying a fraction by a fraction. So what do you do? What do you do? This is what we do. You just multiply the numerator by the numerator straight away. 5 times 5, 1 is 5, over 2 times 5, which is 10. Now, what do? You look at your numerator, you look at your denominator, then you ask yourself a question. Is there any common factor between the two? Yes, the common factor is 5. So you say, okay, 5 into 5 goes 1 time, 5 into 10 goes 2 times. So you have simplified. Now you have 1 over 2 as the final answer. All right? So that's what you do. Don't ever panic when you are working with the mathematics questions. You just have to know the procedure. All right? Let's look at this another example here. Let's look at this example here. Let me change my pen. I don't want to use this blue pen for the answers, right? I prefer using it for solutions and the answers, not the question, okay? So now let's say we have 3 and 1 over 5, and then we have times 3 and 1 over 8, okay? This is where we are. Now, what do we do? 1, what type of numbers am I working with? Mixed fractions or mixed numbers. Okay, mixed numbers, it's fine. What is the basic operation? Multiplication. Okay. Now, what do I do here? If I have a mixed number, it's advisable to convert it to an improper fraction or a vulgar fraction. Okay? So what do? We say 5 times 3. Okay? 5 times 3 is 15, plus 1 is 16. So we are going to say we have 16 over 5. Then times 8 times 3 is 24. 8 times 3 is 24, plus 1 is 25 over 8. Okay? Now, what am I doing here? I'm going to multiply fractions. So if I multiply fractions, all I need to do is to multiply the numerator by the numerator, and then the denominator by the denominator. Okay? Now, when I look at the numerator, 16 times 25, wow, it's a big number. So you may find a way out. Your way out is, you may find your way out and say, okay, can I reduce these numbers? Yes. How do? You can just simplify first. When you simplify, you can just look crosswise like this. Is there any common factor between 5 and 25? Yes, there is. It's 5. So you can say 5 into 5 goes once, into 25 goes 5 times. Okay? Now, crosswise, again, this way. Is there any common factor between 8 and 16? Yes, there is. It's 8. So 8 into 8 goes once, into 16 it goes twice. Now I'm working with small numbers. I have 2 over 1 times 5 over 1. Okay, so now I multiply my numerator by my numerator. Here is 2 times 5 is 10 over 1 times 1, which is 1. So my final answer is 10. Okay, it's 10. All right, it is 10. Okay, now let's continue. Let's continue. There is also about two questions that I want us to do, just to recap on what we discussed in our first part of the revision. Okay, let's look at this problem. I just want to hammer on this. Okay, I just want to hammer on this because it is also common. 1.2 times 10. Work out. What do you do here? You are working with a decimal number and a whole number. Okay, you are multiplying a decimal by a whole number, but this whole number is 10. So it's 10 to the power 1. So once you are multiplying by a power of 10, you are just going to move a decimal. If you are multiplying a decimal number by a power of 10, you are just going to move the decimal sign. You are going to move the decimal sign to the right, to the right. How many times? How many steps to the right? You just count the zeros. If there is 1 0, then you are going to move it once to the right like this. So the answer is going to be what? It's going to be 12.0. Okay, that's all. That's all you do. Okay, that's all. Now let's look at this. Let's look at this. Let's say we have 0.12 multiply by divide. Let me not use multiplication here. Let me use divide. Okay, because we have talked about divide by, say, 100. Okay, what do you do? There is this. There is this. This is 100, and 100 is equal to 10 to the power 2. Okay, it's a power of 10. Now, when you multiply or divide by a power of 10, you're going to move the decimal. So when you divide, you move the decimal to the left, the decimal point here. You move it to the left. How many steps to the left? You count the zeros, 1, 2, 0. So it's going to move 2 steps. 1, 2. The decimal is going to be somewhere here. So what do you do for this position? You place a 0. So you are going to have something like 0.0012. But to be smart, you just say 0. Put 0 there so that it's 0.0012. Even if you don't put that 0, 0.0012 is enough. It's an answer. Okay? So if we multiply or divide by the powers of 10, and we multiply or divide a decimal, that means you just shift the decimal point. You just shift the decimal point either to the right or to the left. So if you are multiplying, you shift it to the right. If you are dividing, you shift it to the left. How many steps? It depends on the number of zeros. Okay? Yes. Now, I believe that what we have looked at so far will benefit you. Okay? It will benefit you. Now, let's go to the next part of our revisions. The next part, I will call it part 2, okay? I will call it part 2. Now, this one, it's about properties of shapes. Properties of shapes. Properties of shapes. Okay? Now, let's say you have this. You have this. You have this, okay? This line is parallel to this one. So the signs here, this symbol, the arrow on these lines, shows us that the two lines are parallel. They will never meet even when extended. They will never meet. They are parallel. Okay. Now, let's say you are given that the angle here is 110 degrees. Okay. And the angle here is say A. Okay. So they want you to find angle A. What do you do? Find angle A. What would you do? What would you do? You need to remember that under this type of questions, where we are dealing with angles between a parallel line and what we call this line. This line is called a transversal. This one is a transversal. A line that cuts parallel lines. A line that cuts two parallel lines, okay, is a transversal. So this line intersects with this parallel line here, and it intersects with this parallel line here. So it's a transversal. So the angle between the transversal and the parallel line, okay, if you are asked to find such an angle, there are certain principles that you apply. You need to know the relationship between these two angles. Their relationship is they are interior supplementary. When you say they are interior supplementary, they are interior because they are inside here. Okay? They are inside here. But they are supplementary because they add up to 180 degrees. So this angle plus this angle must be equal to 180 degrees. So to find A, you can formulate this. You can say, I know that A plus 110 degrees is equal to 180 degrees, okay? And then you solve. This is an equation. You can solve for A now. How do you solve for A? Let's solve for A. We will say minus 110 degrees on the left-hand side of our equation and minus 110 degrees on the right-hand side to balance. Okay, so what we have is 110 minus 110 is 0. So on the left-hand side, we are left with A plus 0, which is A. So it's equal to 180 degrees minus 110 degrees. It's 70 degrees. So the answer here is it's basically 70 degrees. All right? Okay. Now, let's say you have this. Oh my God. Let's say you have this. Ta-ra-ra-ra. Tu-ru-ru-ru. Let's say you have this one. Okay? I'm using my pencil now. Can you see that? It's better to use your pencil sometimes. And then. These are straight lines, okay? Don't mock me. These are straight lines, okay? Now, we have this. Now, we have 35 degrees here, okay? And then we have E here. And then we have D here. We have 25 degrees here. Then we have C here. Then we have F here. So your role or your task in this question is to find angles marked with letters. Angles marked with letters. That means you need to find angle E, you need to find angle C, okay? You need to find DF, okay? Now what do you do? So I would see that this line is parallel to this one. This line is parallel to this one. So there is a relationship between this angle this angle, okay, and this angle. If these two lines are parallel, these two angles are alternate. Angle E and 25 degrees here are alternate angles. Sometimes my lecturer used to say they are Z angles. These are Z angles. This angle and this one are alternate angles. You can use these two Z angles. So they are equal. So that means E equals to 25 degrees. E equals to 25 degrees. Reason, alternate angles. Okay? Now, now we have found E. E is 25, okay? Let me write 25 here, okay? Now, anything again, let's look at another relationship, okay? Now that we have found this one, within this triangle here, this one, we can find this angle, okay? Because we add this and subtract them from 180. So we say 180 degrees minus 35 degrees plus 25 degrees. So what do we get? This is 60. 180 minus 60 is 120 degrees. So this angle here is 120 degrees. And luckily, the angle D and 120 degrees are equal. They are called vertically opposite angles, X angles, if you don't mind. This angle and this angle are vertical opposite and are equal. Therefore, we can say D is equal to 120 degrees, reason vertically opposite angles. Okay? They are vertically opposite angles. All right. Now, we have found this one as 120. Okay? Now, if we have this angle and this one, we can find this one using this, the sum of the interior angles of a triangle. But I like us to use this fact here, this Z angle here, because C and 35 here are alternate angles, so they are equal. So C is equal to 35 degrees. Reason, alternate angles. Okay? Now, this is 35 degrees, okay? Then F is also 35 degrees because they are vertical opposite with C. These two angles are vertical opposite. Vertical opposite angles. So now we have revised the issue of properties of shapes, basing ourselves on alternate angles, vertical opposite angles, interior supplementary angles. Okay? If this question had allowed us to also move on to corresponding angles, we would be happier, but it doesn't matter, okay? It doesn't matter. It doesn't matter. We are happy for what we have discovered in this question, okay? We are happy. I don't know about you, but I am happy, okay? Now, let's go to the next part. Let's go to the next part of our revision, where we are going to be looking at an interesting concept. Collecting like terms. Collecting like terms. Collecting like terms. Okay? Now, when you collect like terms, sometimes we talk of simplifying. Simplifying, okay? collecting like terms, or simplifying. Okay, let's say you have yeah, the question would say simplify. Simplify. The question would just say simplify. Okay, so let's say you had this question. Then they say simplify. What do you do? What do you do? To simplify in this scenario, it's to remove the brackets. Okay, so that would be removing the bracket. You take this 5, you multiply this first term in the bracket, and you take the same 5 and multiply the second term in the bracket. So you need to understand that this is positive 5. You need to understand that this is positive 3x and this is positive 4. So positive 5 times positive 3x is going to be positive 15x. Positive 5 times positive 4 is going to be positive 20, because positive by positive is positive. Positive by positive is positive. Okay? Now, there are two terms here, but these are variables of x, and this is just a constant. Now, so there is nothing else you can do about this. These two terms are distinct. Then you leave it like this. It's simplified. Let's look at this one. I've said my own. Okay? Let's look at this one. This one, we remove this bracket and then remove this bracket and see what we have. So how do we remove this? We multiply this by this and this by this. Here we are going to multiply this by this and this by this. Okay? So 2 times 3a, positive 2 by positive 3a is positive 6a. Positive 2 by positive 4 is positive 8. Positive 5 by positive a is positive 5a. Positive 5 by negative 1 is negative 5. Okay? Yeah. Now, how many terms do we have here? We have 1, 2, 3 terms, as opposed to here. Here we had 1, 2 terms. Okay? Now, since we have 4 terms, these two, this one and this one, they are like terms. So we have to collect them. When we collect them, we group them. That is 6a plus 5 plus 5a. Then plus 8 minus 5. So these are like terms. These are also like terms. So let's simplify this. 6a plus 5a is 11a. 8 minus 5 is positive 3. So this is the answer, simplified. Okay? That's the answer, simplified. All right. Let's look at this one. 13 plus 2, 3m minus 5. Simplify. Then 13, here we have positive 2 times 3a. This one times this. This one times this. Positive 2 times 3m is positive 6m. Positive 2 times negative 5 is negative 10. Okay? So we have 1, 2, 3 terms. Now, these two are like terms because they are both constants. Now we are going to have 13 minus 10. This is collecting like terms, plus 6m. Now we simplify 13 minus 10. It's 3. Then plus 6m. This is the answer. Okay? That is the answer. All right. That is basically what I wanted us to look at today. I wanted us to look at this, and I believe that you will be happy. Okay, let's look at another thing here. Let's look at another thing here. In this topic, now we are going to look at finance. Or financial mathematics. Okay, there will be questions in the exam whereby you will be dealing with money. All right, now let's have an example here. I have an example. Sipho has P Malodi and Thandi has C Malodi, more than Sipho. Sipho has C Malodi and Thandi has Sipho has P Malodi and Thandi has C Malodi more than Sipho. So the question says, so we have two candidates here. We have Sipho, Sipho's, and then we have Thandi. Okay, so they have some money. So Sipho has, this one is Sipho, this one is Thandi. All right, so Sipho has C Malodi, Malodi C. Okay, and then this one has no, it's P Malodi here. Let me just do this. Let me not confuse my dear friend. Let's say P Malodi, like this, okay? And this one has C Malodi more than Sipho. More than Sipho. Okay? Now, that's what the information is actually telling us. Now, the first question here says, how long, it says, how much money has Thandi? How much money has Thandi? C Malodi more than Sipho, that means it's the answer here is that it's this. So if she has C Malodi more than Sipho, that means it's Sipho's money plus C. That means it's P plus C, okay, Malodi. That's her money. Sipho's money plus C, because it's C Malodi more than Sipho. Okay, she has C Malodi more than Sipho. That means she has Sipho's money plus C. That's her total amount. Okay. Now, Nomza, there is another person coming in. Nomza has twice as much money as Sipho and Thandi together. How much money does Nomza have? Nomza has twice, okay? Has twice as much money as Sipho and Thandi together. So Sipho and Thandi together would be, Sipho is P, okay? And then Thandi is this one, P plus C. Then Nomza is twice this, 2 times this. together. So this is Nomsa's money. So we can simplify it and say we have 2 bracket 2p plus c. When you simplify this, p plus p is 2p, right? P plus p is 2p, so we have 2p plus c. Now, we can still simplify this further and say, okay, we are going to have 2 times 2p, which is 4p. Then 2 times c is 2c. All right? So that would be Nomsa's money.